the RadiaSoft website. You can access to this website and you can go to register your email. Then you will get the email for the password. Then you can use the Radia on cloud. You don't have to use the Radia installation on your local PC. So after permission from the Sirepo cloud, you can go entering this cloud services. If you go to Radia Sirepo directory, you can have example file. For example, you can see this Jupyter format Python script notebook. So you can see all clearly categorize and explain for each code. Go back to the home directory. If you go to Radia GitHub, I copy this file from the original Radia Python GitHub website here, and as you can see that the example Python script available. So this file uploaded in the new directory, so you can actually run from this terminal. And so you can have a result here. Peak magnetization. Save the picture here. So this is the magnetic field along the multiple wiggle. So you don't have to install the Radia on your local. You don't have to have local PC to run the Radia. You can actually run in the cloud services. Now go back to home directory. We go to Radia ID. The Radia ID file I get from ESRF GitLab website. The Radia ID facilitate to make undulator or multiple wiggler more easily on Python script. So you can copy this file, upload it to the cloud services here. And the script from multiple wiggler I modify from the original. We can run this script even in the cloud services. Python Jupyter notebook is also available. So this is the make a Jupyter notebook from the original Python script. And you can run on the cloud. You can load if you have run previously, or print the result, export object for next calculation, save the VDK file for magnet geometry. However, we cannot preview this model on the cloud services. The field computation, transfer field distribution, electron trajectory in transverse direction, field integral. If you want to run, you just enter or shift and enter. This is the original Jupyter notebook from Radia ID, slightly different. If you want to run, the original Python script. So you go back to home directory. So as you can see, you can have a result printed, and you also see the object file for next calculation and VDK file for geometry, magnet geometry preview. You can upload from here or download from just click download. If you are not familiar with the Python script, this Sirepo website by RadiaSoft company provide the web application. It's called Magnet. So you can simulate some interactive design. So you can add the gap, number of pole length, and pole size, pole material, permanent magnet size, and permanent magnet material. And there's a termination also. You can design at the end or the beginning of the regular or multiple undulator.